Jai Hind to everyone. In this lecture of control system KEC 602, I am going to discuss about the block diagram reduction. So, I am Dr. Karunesh Srivastava, Associate Professor in Electronics and Communication Engineering Department of Akgec Engineering College. So, in this lecture, I am going to discuss about the block diagram reduction. First of all, what is block diagram reduction? It is simplification of block diagram via certain arrangements, and the simplification results in easy calculation of transfer function of overall system. So, what are the rules of the block diagram reduction? Rule 1, if when blocks in cascade, when two blocks are connected in cascade, it means output of first system is working as input of second system. So, here you can see that US is an input and US G1S is an output of this system. So, this is working as an input for this system 2. So, what will be the overall output for the system? US G1S G2S. So, we can say that we can reduce this block diagram when two blocks are connected in cascade. We can rewrite the block diagram, resultant block diagram like this. US is as an input, G1S and G2S, these are the gain of the individual system gain. G1S is the gain of system 1 and G2S is the gain of system 2. So, the gain of individual system will be multiplied when we are connecting two systems in a cascade connection, and the output will be US G1S into G2S when two blocks are connected in parallel. So, here two blocks are connected in parallel, G1S and G2S is connected in parallel. So, the output for this system is US G1S, output for this system is US G2S. So, what will be the resultant output? Resultant output will be the summation of these outputs. So, we can write the resultant block diagram like this: G1S plus G2S as a resultant gain of the parallel connection, and US is as an input. So, the resultant output will be US G1S plus G2S. Next is feedback loop. Here GS is the forward path gain and HS is the feedback path gain. So, here you can see that YS is an output. This YS is connected to the input US via feedback HS. So, what will be the resultant output? This is the error signal ES. So, we can say that the output of this feedback path is equal to YS into HS. YS will work as a input and HS is the feedback gain. So, the output for this feedback path will be YS, that is working as an input, and gain HS. So, this will go to the summing point and you will get here the error signal. You can consider here the negative sign. So, what will be the output? Output will be equal to GS upon, if I am considering here positive sign, then it will be equal to GS upon 1 minus GSHS. If I am considering here the negative sign, negative feedback, then the output will be GS upon 1 plus GSHS. Here we can consider, we can easily find the YS by HS by putting the value of ES and US. So, here I can see that YS is nothing but, this is the error signal ES into GS. What is the value of ES? ES is nothing but US minus YS HS. So, I can put here US minus YS HS and this is GS. What I want here, I want YS in terms of US. So, what will be the value of YS by US? YS by US will be equal to, if I transfer this factor to this side, I will get here 1 plus GSHS into YS is equal to US GS. So, here you can see that YS by US will be equal to GS upon 1 plus GSHS. Similarly, you can find for positive feedback system. This is for negative feedback system and this is for positive feedback system. Coming to the next, summing point interchange. how will you change the whenever I am using the block diagram reduction procedures or block diagram reduction rules, the intention is to getting the same output whatever we are getting without manipulation or without changing the block diagram reduction method, without using the block diagram reduction method. So here you can see that we are getting the output u1 plus minus u2 plus minus u3. This is the summing point. Here I have given the u2 as an input, so I will get here u1 plus minus u2. Here I will get here the u1 plus minus u2 is here input and u3 is this, so I will get here u1 plus minus u2 plus minus u3. If I interchange the summing point, then what will happen? u1 plus minus, I am interchanging this summing point like this. I am shifting this point, this u3 summing point towards u1 and this u2 is shifting towards the output. So what will I get? u1 plus minus u3, and here I will get u1 plus minus u3 plus minus u2. So the output is same if I am changing the summing point, if I am interchanging the summing point. Now next rule is moving a summing point after a block. So if I am shifting the summing point towards the block, after a block, the output should not change. Before shifting the summing point after the block, the output is, here I am getting u1 plus minus u2, this is the gain, so I will multiply this, the resultant input, to the gain. What will be the output? GS u1 plus minus u2. If I shift this summing point to this position, then what will happen? If I shift the summing point to this position, then u1 is as an input, I will apply this to g1s, and if I shift here this u2, then what will I get? Here the output for this is u1 g1s, and if I use here this summing point with plus minus sign, then what will I get here? u1 g1s plus minus u2. But the desired output is this g1s u1 plus minus g1 2 us. So here one more g1s is required, multiplication of g1s is required in u2 term. So what will I do? I will multiply this. I will multiply this input u2 with the gain, after which we are shifting the summing point. So here you can see that this is the u1 g1s. Here I am getting g1 gs u1, and the desired output is gs u1 plus minus gs u2. So what I have to do? I will multiply the gain of that block, after which I am shifting the summing point. So here I will get g gs multiplied by u2s. Now if you see here, I will get gs u1 plus minus u2, that is my desired output. So in this way we can shift the summing point after the block. Now coming to the next rule, moving a summing point ahead of block. Now if I shift the summing point before the block, now again after the block I have multiplied with the system gain gs. when we have shifted the summing point after the block, then we have multiplied with the system gain gs. Now I am shifting before a block, then what will I do? I will divide by the gain before which I am shifting the summing point. I am shifting the summing point before this block. So what will I do? I will add a block having a gain 1 by gs. So you can see here here the desired output is gs u1 plus minus u2. Here the output is u1 plus minus u2 gs by gs. What I have done? I have divided by the gain of the block before which I want to shift the summing point. Now here you can see I am getting the same output. Next, moving a takeoff point after a block. you can see here, this is the takeoff point. If I see the output of this takeoff point is u, and the final output of the block diagram is u into gs. If I shift this takeoff point after the block, then what is going to happen? I should get this output after shifting the takeoff point, but I will not get here us as a output of takeoff point. Here, if I shift here, I will get here u into gs. Then what I have to do? I have to divide by the gain of the block after which I want to shift the takeoff point. So here I want to shift the takeoff point after this block. So what will I do? I will add a block having a gain 1 by gs. So the desired output will become here us, and this output is u into gs. Now next is moving a takeoff point after a block. I will again get here us, but the desired output is u into gs. Then what will I do? I will multiply by the gain of the system before which I want to shift the takeoff point. So I am shifting this takeoff point before the block, this gs. So what I am going to do? I am going to multiply this. This is the input is us. If I multiply this by this, you will get here u into gs. Moving the takeoff point ahead of summing point. Moving the takeoff point ahead of summing point. I am shifting this takeoff point ahead of summing point. So the requirement is same. The output should not change. Here I am getting the output y, here I am getting the output y. So output y is nothing but u1 plus minus u2. So if I shift this takeoff point, this output will be same, but for maintaining this output y as a u1 plus minus u2, what changes I have to do? Here if I shift this takeoff point here, I will get here only u1, but the required output is this u1 plus minus u2. Then what I have to do? I will add one more summing point with the input u2. If I apply the input u2 at this summing point, what will happen? It will add this input u2 with the input u1. Then the output of this summing point will be u1 plus minus u2. Now next is moving a takeoff point beyond a summing point. Now I want to shift this takeoff point after this summing point. Now you can see here again the output is same, u1 plus minus u2. So u1 plus minus u2, what will I get here? I want the summing point, the output of this summing point is u1. Output of this summing point is u1. So this output of this summing point should be u1. For getting this u1, what will I do? I will subtract from this. I am getting here u1 plus minus u2. So what will I do? I will add and subtract for getting this u1. So I will subtract and add minus plus u2, so that it will become it will nullify this u2 by minus plus u1 minus plus u2, and I will get here u1. So now I am coming to the reduction rules of the block diagrams. So for reduction purpose, you can follow or you can use these rules for simplification of the block diagram. First rule is check for the blocks connected in series and simplify. First of all, you have to identify whether the blocks are connected in series. If they are connected in series, then you will first of all you will simplify the series connected blocks or cascaded blocks. Second rule is that you have to identify the parallel connection in the block diagram. Identify and simplify them by using the rules that I have told you. In rule 3, check the block diagrams are connected in feedback loop. That is the standard form of the closed loop system. First you will identify the standard form of the closed loop system. If there is any blocks connected in standard format of the closed loop system, then simplify that block diagram. Rule 4, if there is difficulty with takeoff point while simplifying, if there is difficulty in takeoff point while simplifying, then shift the takeoff point towards right. Towards right means you are trying to convert that by shifting the by shifting the takeoff point to the right, you are trying to convert the or trying to simplify the block diagram in a standard form of the standard closed loop form of the system. And the fifth rule is saying that if there is a difficulty with summing point while simplifying, shift the summing point to the left side. I mean to say, suppose X RS is an input, GS, CS, HS. This is this. So if you are shifting towards right, then shifting the takeoff point towards right and shifting the summing point towards left, then you are trying to convert the given block diagram in the standard canonical form of the closed loop system. So in rule 6, repeat the above steps till you get the simplified form, that is single block diagram. So these are the rules for converting, for reducing, for simplifying the block diagrams. Let us take an example. This is the example you can see here. Here you can easily see the block diagrams are connected in parallel as well as closed loop format and as well as standard closed loop system. So here first of all we have shifted the takeoff point before the block G2. So in the previous block you can see here what I have done, I have shifted this takeoff point before the block. So by shifting this before the block, what I have done, I have multiplied with the gain of the block before which you have shifted the takeoff point. Now I have shifted the takeoff point before the summing point. Now what happened? I have multiplied, I have shifted the takeoff point before the summer. So you can see here this summer has been splitted. Takeoff point, I have shifted this takeoff point before the summer. So in this block you can see here I have shifted this here. So this takeoff point is connected with this. So you can shift this block diagram or you can consider this summer as here. So I have considered this summing point here, and you can see here this block diagram. In this block diagram, this is the summing point. You can use this as a feedback path and you can also use as a parallel connection. So here what I have done, I have splitted this summing point into two parts. Before splitting this summing point into two parts, I have shifted this takeoff point after the block G2. So here by shifting this, after shifting this summing point after the G2, what I have to do, I have to multiply by the gain of the block after which I have shifted the takeoff, after which I have shifted the summing point. So this is the resultant block diagram, and after that you can interchange the summing point that I have already told you. So after doing all these exercise, you will get, you can see this G2 and G3, this G2 and G3 is connected in parallel, this G2 and H2 is connected in series. So what will you get here? G2 plus G3 and G2 H2, and this H2 is connected with this. So you will get this. After that you can see that this is the closed loop system of the standard closed loop system. So you will get here G1 H1 G2. Now you will get this is connected to minus G2 H2. So this is minus G2 H2, this is connected with this. So you will connect with this. So the resultant block diagram will be like this, and the final answer will be, this is the G1 upon 1 plus H1 G2 H1 G1 G2, and this is G2 plus G3, this is 1 by 1 plus G2 H2. These are connected in series and this is connected in feedback. So this will be the final block diagram reduction. So in this way you can simplify or reduce the block diagram by using all the rules. Thank you. I will discuss in the next lecture.